Hey there, tech enthusiasts. Welcome back to Circuit Lab Studio. Today, we're taking a trip back in time to explore the Intel 8086 microprocessor, the grandfather of modern computing. Did you know? Your computer's processor today is based on the same x86 architecture that started with the 8086. Mind-blowing, right? In this video, we'll cover what is the 8086 microprocessor? How does its architecture work? Why is it still relevant today? So buckle up and let's dive right in. Chapter 1. What is the 8086 microprocessor? So what exactly is the 8086 microprocessor? Well, it was designed by Intel in 1978 and became the foundation of today's x86 architecture. Here are some key facts about it. It's a 16-bit processor, meaning it processes data in 16-bit chunks. It has a 20-bit address bus, allowing it to access 1 megabyte of memory, which was a lot back then. Clock speeds range from 5 to 10 megahertz, super slow by today's standards, but revolutionary for its time. The 8086 was used in early personal computers, including the original IBM PC. And fun fact, even modern Intel processors can still run code originally written for 8086. Now that's some serious legacy power. Chapter 2. 8086 Architecture Overview. Now let's break down the architecture of the 8086 microprocessor. It's divided into two main parts. Bus Interface Unit, BIU, handles communication with memory and instructions. Execution Unit, EU, actually executes instructions and performs operations. Let's dive deeper into these units one by one. Chapter 3, Bus Interface Unit, BIU. First up, we have the Bus Interface Unit, BIU. Think of this as the communication center of the microprocessor. Here's what it does. Instruction fetching. It fetches instructions from memory and stores them in a 6-byte queue for faster execution. This is a form of pipelining. Memory addressing. The BIU calculates the physical memory address using something called segmented addressing. The formula is physical address equals segment address times 10H plus offset address. Segment registers. The 8086 organizes memory into 64 kilobyte segments using these four registers. CS, code segment, holds the program code. DS, data segment, holds program data. SS, stack segment, manages function calls and stack operations. ES, extra segment, used for additional data. Let me show you how segmentation works. This technique allowed the 886 to access a whopping 1 megabyte of memory, which was huge back then. Chapter 4, Execution Unit, EU. Now let's talk about the execution unit, EU, the brain of the processor. This is where actual computations happen. The EU consists of arithmetic and logic unit, ALU, performs math and logic operations. Registers, small storage locations inside the CPU. AX, accumulator, main register for calculations. BX, base, used for memory addressing. CX, counter, used in loops. DX, data, holds extra data pointer and index registers. SP, stack pointer, tracks the stack. BP, base pointer, helps with function calls. SI and DI, source and destination index, used for memory operations control unit and instruction decoder. Reads and interprets instructions. Flags register, stores important condition flags like carry flag CF, zero flag ZF, etc. Chapter 5. How 8086 communicates. System buses. How does the 8086 communicate with memory and external devices? It uses 3 buses. 1. Address bus 20-bit, selects memory locations. 2. Data bus, 16-bit, transfers data between the CPU and memory. 3. Control bus, manages signals like read, write, and interrupts. Chapter 6. Key features of the 8086. To wrap things up, here are the key features of the 8086 microprocessor. Checkmark 16-bit processor with a 20-bit address bus, checkmark supports. Pipelining, 6-byte instruction queue. Segmented memory architecture supports both minimum and maximum modes. Clock speed, 5, 8, or 10 megahertz. Chapter 7. Why is 8086 still important? You might be wondering, why should I care about an old processor from 1978? Well, here's why. Modern Intel and AMD processors are still based on the x86 architecture. Many legacy systems still run on 8086 compatible processors. Understanding 8086 helps you grasp the basics of computer architecture. Did you learn something new today? Let me know in the comments below. Also, don't forget to like, share, and subscribe for more tech videos. Thanks for watching, and I'll see you in the next one.